Direct reduced iron, also called sponge iron, is produced from direct reduction of iron ore by reducing gas produced from natural gas or coal. Reduced iron derives its name from the chemical change that iron ore undergoes when it is heated in a furnace at high temperatures in the presence of hydrocarbon-rich gases. Direct reduction refers to processes which reduce iron oxides to metallic iron below the melting point of iron. The product of such solid-state processes are called direct reduced iron. The reducing gas is a mixture of gases, primarily hydrogen and carbon monoxide. The process temperature is typically 800 to 1050 degrees Celsius. Direct reduction processes can be divided roughly into two categories: gas-based and coal-based. In both cases, the objective of the process is to drive off the oxygen contained in various forms of iron ore, in order to convert the ore, without melting it, to metallic iron. The direct reduction process is comparatively energy efficient. Steel made using dry requires significantly less coal, in that a traditional blast furnace is not needed. Dry is most commonly made into steel, with electric arc furnaces to take advantage of the latent heat produced by the dry product. In modern times, direct reduction processes have been developed to specifically overcome difficulties of conventional blast furnaces. Dry is successfully manufactured in various parts of the world through either natural gas or coal-based technology. The initial investment and operating costs of direct reduction plants are low compared to integrated steel plants and are more suitable for developing countries where supplies of coking coal are limited. Factors that help make dry economical. Direct reduced iron has about the same iron content as pig iron, typically 90 to 94% total iron, as opposed to about 93% for molten pig iron. So it is an excellent feedstock for the electric furnaces used by mini mills, allowing them to use lower grades of scrap for the rest of the charge to produce higher grades of steel. Hot briquetted iron is a compacted form of dry designed for ease of shipping, handling, and storage. Hot direct reduced iron is iron not cooled before discharge from the reduction furnace, that is immediately transported to a waiting electric arc furnace and charged, thereby saving energy. The direct reduction process uses pelletized iron or a natural lump ore. One exception is the fluidized bed process, which requires sized iron ore particles. Few ores are suitable for direct reduction. The direct reduction process can use natural gas contaminated with inert gases, avoiding the need to remove these gases for other use. However, any inert gas contamination of the reducing gas lowers the effect of that gas stream and the thermal efficiency of the process. Supplies of powdered ore and raw natural gas are both available in areas such as northern Australia, avoiding transport costs for the gas. In most cases, the dry plant is located near natural gas source, as it is more cost-effective to ship the ore rather than the gas. This method produces 97% pure iron. India is the world's largest producer of direct reduced iron, a vital constituent of the steel industry. Many other countries use variants of the process, so providing iron for local engineering industries. Problems. Directly reduced iron is highly susceptible to oxidation and rusting if left unprotected, and is normally quickly processed further to steel. The bulk iron can also catch fire since it is pyrophoric. Unlike blast furnace pig iron, which is almost pure metal, dry contains some siliceous gangue, which needs to be removed in the steel-making process. History. Producing sponge iron and then working it was the earliest method used to obtain iron in the Middle East, Egypt, and Europe. where it remained in use until at least the 16th century. There is some evidence that the bloomery method was also used in China, but China had developed blast furnaces to obtain pig iron by 500 BCE. The advantage of the bloomery technique is that iron can be obtained at a lower furnace temperature, only about 1100 degrees Celsius or so. The disadvantage, relatively to using a blast furnace, is that only small quantities can be made at a time. Uses. Sponge iron is not useful by itself, but can be processed to create wrought iron. The sponge is removed from the furnace, called a bloomery, and repeatedly beaten with heavy hammers and folded over to remove the slag. Oxidize any carbon or carbide and weld the iron together. This treatment usually creates wrought iron with about 3% slag and a fraction of a percent of other impurities. Further treatment may add controlled amounts of carbon, allowing various kinds of heat treatment. Today, sponge iron is created by reducing iron ore without melting it. This makes for an energy-efficient feedstock for specialty steel manufacturers which used to rely upon scrap metal.